So in this video, I'm going to discuss some problems for a short course organic chemistry students, and this is not a course for pre-meds or chemistry majors. This is a course for biology majors who want to just take chemistry as one of their requisites. So therefore, I won't be discussing things in very much detail, but I do want to discuss it in sufficient detail that you will understand the concepts required to do well in your course. So the first question I want to discuss is for alkene reactivity. So in this problem, they ask you to predict the structure of the molecule that results when each of these alkenes react with one equivalent of bromine. So when they say bromine, we should recognize that it's Br2 molecule and not just a Br atom. So let's say, for example, we are looking at problem F. So this is a 1, 2, 3, 4, 5 carbon chain, 2, 3, 4, 5, and then you have a double bond on the second carbon, and then you have a CH3 here. Of course, the way they have drawn it, it could be a cis or a trans molecule. There is no way to tell which one exactly they are talking about, so both should be equally acceptable as a reactant based on the lack of stereochemical information in this question. Anyway, so now if this reacts with Br2, then the product is simply going to be add 2 bromines to the molecule. Therefore, it's going to be a bromine here and a bromine there. So that is the product of this reaction, and there is only one possible product here as long as the regioselectivity is concerned. Now if the same question was predict the product when this reacts with HCl, let's say, then based on the Markovnikov's rule, this carbon is going to get a hydrogen, and that will end up putting a positive charge on the carbon here. So I'm writing a mechanism, but I'll tell you what the product structure is shortly. So when the hydrogen in the form of a proton adds to this double bond, this carbon ends up getting the new hydrogen. You get a positive charge here, and now the Cl minus is going to attack the carbocation, giving you that as the major product, and the minor product is going to be obviously the chlorine on that carbon atom here. Okay. Now let's say the same question asks you to predict the product when this reacts with acid and water, or reacts with water in the presence of acid, which is called as the acid catalyzed hydration of alkenes. So when that happens, the H plus first attacks the double bond here. Therefore, we will go back to the same line structure, and this has the methyl group here. So if this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then carbon number 2 gets the proton. Therefore, you get a hydrogen there, and you will put a positive charge, which is the intermediate. And now when water reacts as a nucleophile, it's going to donate electrons to that carbon, so it ends up making a carbon-oxygen bond. So I'm not going to show this hydrogen explicitly anymore, but you do need to know that. And you have OH2 with a positive charge on the oxygen, and the oxygen is going to kick this hydrogen off as H plus because it wants to remove its positive charge and become neutral. So it takes up the electrons that is part of the sigma bond here, and you'll end up having OH in this molecule, and this hydrogen that is being kicked out comes out as H plus, and initially the first proton that you had in the medium is now part of the molecule here, and the proton that was part of water now gets kicked out. Therefore, a proton goes in, a proton comes out, and that means this is a catalyst. Therefore, at any given point of time, the amount of acid is going to be the same. Even though it's going to initiate the reaction, it's going to be regenerated at the end of the reaction. So water by itself is not strong enough to add to an alkene, so adding a small amount of acid like this is going to let this reaction go at a faster rate, because acid is a stronger electrophile than the H plus generated by water. So when they say H plus, it's going to be a small amount of acid. So the same problem can be represented as, or given as, what is the product when this alkene reacts with H2O in a small amount of HCl, with a small amount of HCl. So they can say catalytic amount of HCl, and that means they're talking about that H plus being added to the medium as a catalyst. So H2 is the primary nucleophile in this case. Alright, so that is basically what you want to know for the problem.